part, we derive the labor demand curve, we expressed N as a function of W. Now, in the second part, we want to find the equilibrium level of real wage and employment. So, we know equilibrium in this model of the labor market occurs where labor demand and labor supply intersect, right? So, where ND and NS intersect, right? So, labor market equilibrium in this model is where ND is equal to NS. Now, a labor demand equation is given to us as ND. This is given to us as which we found in part A as 12.5 by W square. And labor supply equation is given in the question, which is 100 W square. So now setting the two equal in equilibrium, we know in equilibrium we set the two equal. So when we set the two equal, so this is 12.5 by W square is equal to 100 W squared. So then now what we can do is, since we have a square on both sides, let's take a square root on both sides. This becomes 12.5 by W. This becomes 100 square root is 10 and this becomes W. So this is 12.5 by W is equal to 10W. Now let's just have W on one side. So 12.5 by 10 is equal to W square. So from here we know that W squared is just 1.25. So then this means the equilibrium real wage is 1.25 square root in exact form. Right, so this is the equilibrium real wage. Now that we have the equilibrium real wage, we can find the equilibrium level of employment as well. So now we can insert it into any one of the equations of labor demand or labor supply. Now inserting W star into labor supply equation, which is NS, to get N star, which is the equilibrium level of employment. So that's going to be, we know this is 100, that instead of W, we just put here 1. We know W star is, now inserting W star into this, so W star is, we found 1.25 under root and the square, right? So this we have plugged it in this equation of the labor supply curve, right? 100 times W square, and this is like W, which is under root 1.25. So then this just becomes simply 100 into 1.25 because the square and square root cancel each other. So the equilibrium level of employment is 125. Obviously, we found the equilibrium level of employment by plugging in the equilibrium level of the real wage and labor supply. Alternatively, we could have also plugged in W star in labor demand equation to get N star, right? We could have done that. Basically, we could have done this. N star would have been 12.5 divided by, because this is W, right? And W was like under root 1.25 whole square. You could have found it like this also, right? This was your labor demand equation, right? So the idea is just once you have the equilibrium real wage, you can plug it either in your labor demand or labor supply equation to get the equilibrium level of employment, because equilibrium is at the intersection, so you'll get the same answer regardless of whether you plug it in labor demand or labor supply equation. So now we're done with this. Let's do the last part of this, which is you want to find the full employment level of employment. Here we need to keep in mind in this model, labor market equilibrium determines the labor market equilibrium determines the full employment level of employment, which is N star. So basically, in the labor market equilibrium, once we find the equilibrium level of employment, it's the full employment level of employment, or what we call the natural level of employment. So now if we plug this equilibrium value of N, which we know is N star is 125 in this case, in the production function, which is y is equal to 25 and 0.5. You get full employment level of output. Y star. So Y star is just going to be 25 n star 0.5, and we know n star is 125 into 0.5, so this is going to be 279.5. So labor market equilibrium gives us the full employment level of employment. So once we plug in this full employment level of employment in our production function, we can get full employment level of output.